previous session we learned about the concept introduction to the concept name is introduction to probability. So the next concept is about joint probability, joint probability, and conditional probability, joint probability and conditional probability. This is the next concept. So joint probability and conditional. So the joint probability, the joint name indicates joint means there should be at least two events. So namely A and B. So if you assume A and B are two events, then the joint probability of two events is represented by P of A intersection B. P of A intersection B, which is equal to P of A plus P of B minus P of A union B. So suppose if we want to find out the joint probability of two events, so it is represented by like this: P of A intersection B equal to P of A plus P of B minus P of A union B. So P of A, P of B, P of minus A union B. So A and B are called individual probabilities. So A union B is the combined probability, and the total, this one is called joint probability. Okay, we'll see problems later in around this topic, regarding this topic. So the next one is the next name is conditional probability. Conditional probability. So the conditional probability is always represented like this: P of A given B. A given B. Sometimes the students call this one as A by B. So we should not call this one as A by B. It is A given B. That means the probability of event B already given. From that you have to calculate the probability of an event A. So this is called the uh, conditional probability. So the formula of conditional probability is given by P of A given B is equal to P of A intersection B divided by P of B. So this is the probability of conditional event. So if at all, so to remember this formula, just see here it is A, it is B. So in the denominator you are having B. That's why on the right side in the denominator part also you have B. And here you are having two events A and B. On the numerator you are getting their joint probability. So P of A intersection B. So the condition probability is given like this. So P of A given B equal to P of A intersection B divided by P of B. So to do problems, so we should compulsorily remember these two formulas. So one is joint probability and another one is conditional probability. So now moving on to the next one. So we'll see some problems on this. So the problems, suppose take this one. So see this problem. In a box, there are 100 resistors having resistances and tolerances as shown in table 1.41. So I will tell you the table. So the table is like this. The table is like this. So I am going to draw the table. So the table is like this. The first column is resistance. The second column is tolerance. The third column is total number of. So here it is tolerance. You are having two types. One is 5% tolerance, another one is 10% tolerance resistance. So here the resistance values are, first one is 22 ohm resistance. So 22 ohm resistors having 5% tolerance, 10 resistors, and 10% tolerances you are having 14, and 10 plus 14 total 24 22 ohm resistors. Next one is 47 ohm resistance. So here 28, and this one is 16, and total you are having 40. Sorry, 44. 44. Next one, 100 ohm resistors. So here 5% tolerance are 24, and it is 8, totally 32. So if you add all this together, here we are having a total of 100 resistors in that box. So this is the table. So let's first study this problem. So in a box there are 100 resistors having resistances and tolerances as shown in table. So the table is like this. So here we are having three types of resistors: 22 ohm, 47 ohm, 100 ohm. And here we are having two tolerances, 5% tolerance and 10% tolerance, and having like this. So 10, 14, 28, 16, 24, 8, 24, 44, 32, like that. So they will give you table. So here they will define three events. See here, define three events like A is draw a 47 ohm resistor, B is draw a resistor with 5% tolerance, and C is draw a resistance of 100 ohm register. So now see, I'm going to define, first I am going to define the events my. So suppose I want to find out the event probability A. So what actually A represents? A represents draw a 47 ohm resistor. So we have to move here. How many 47 ohm resistors? The 47 ohm resistors might be 5% or might be 10%. So how many total 47 ohm resistors? 44. Out of how many? 100. So the P of A is equal to 44 divided by 100. This is the event A probability. Next one. Suppose I want to find out the probability of B. Probability of B. Now what they told you, what is the probability of B? Probability of B means here they ask you, B means draw a resistor with 5% tolerance. So resistance with 5% tolerance. So 5% tolerance means it might be 22 ohm resistor, 47 ohm resistor, 100 ohm resistor. So all together, if you add all this together, it might be how many? 28 plus 10, 38 plus 24. Totally here we are having 62 5% tolerance transistor, I mean resistors, and it is 38 38 10% tolerance resistor. So totally, if you want to find out the value of P of B, it will be 62 divided by 100, P of B. So now finally P of C. P of C. So what is P of C here? P of C means draw a 100 ohm resistor. So how many 100 ohm resistors are there here? So 24 plus 8. So totally 32 resistors. That is 32 divided by 100. So we have find out the individual probabilities. Now I want to calculate the conditional probabilities. How I will define the conditional probabilities? Let's see here. So suppose I take P of A given C. P of A given C. Meaning what? So you have to, meaning means here just this remember, this means what? A given C. That means you have to take A means what? Here A means 47 ohm resistor. C means what? 100 ohm resistor. So that means fine. Take out the 47 ohm resistors, and that 47 ohm resistor must also be 100 ohm resistor. That means there is no possibility of resistance which is having two values, 47 and 100 ohms. So that's why I can say that P of A intersection C divided by P of C, this value, and my A intersection C is equal to, there is no common resistance. That's why it is a null set and implies probability is 0 divided by P of C. That means P of A given C is equal to 0. That's how you have to do. Suppose another example. You have to find out the p of a given b. That means, so how it is pronounced means, take out the 47 ohm resistor which is having a b is condition is which is having b means that b condition here is what it is. B means 5% tolerance, 5% tolerance. That means it is 47 ohm resistor with 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 5% tolerance. That means how many 47 ohm resistors with 5% tolerances here? Totally 28. So that's why it is 28 divided by 100 and divided by what is p of b? We already know it is 62 by 100. So that means there is 62 by 100. So 100 get cancelled, which is equal to 28 divided by 62. 62. Suppose you want to calculate the another one, last example. If you want to calculate the P of B given C, that means it is P of B intersection C divided by P of C. So how to find out P of B intersection C? B intersection C means B means 5% tolerance resistance and C means 100 ohm resistance. That means 100 ohm resistance with 5% tolerance. So come to here. What is 100 ohm resistance with 5% tolerance means here you are having 24 number of resistors, and finally you are having what here it is 24 divided by 100 and divided by what is p of c? We already know that it is p of c, it is equal to 100. So 100 get cancelled, it is equal to 24 divided by 32. So this is the way of calculating conditional probability. So conditional probability means you should know the uh, condition. Condition is given by denominator one. I mean that means b given c. This c is condition and you are calculating the event probability b. Okay. This is the one of the problem, very important problem while calculating the conditional probabilities. So moving on to the next one. The next concept is uh, one second. The next concept is additional theorem of probability. The next concept is additional theorem of probability. Additional theorem of probability. So this is nothing but the statement is like this. So the additional theorem of probability states that the joint probability of event, that means we already know, we just know we have a formula, right? Joint probability formula. P of A intersection B equal to P of A plus P of B minus P of A intersection B. So the proof of this expression is called the additional theorem of probability. Additional theorem of probability. So to do this one, we should know the Venn diagram. We already see in the intermediate itself how to find the how to write like this. So suppose I am assuming this as A, this as B, and this one. One second. And this one is called A intersection B, and this one is called superset or universal set. So these are you have to remember, you have to write. So now from here I can say that these two are common. They suppose A is an event, B is an event, another event. So if you see here we can write like this. From the figure you can see the A union B can be written like this. So the A union B is equal to A sorry, A union of B minus A. A union of B minus A. That means see here how it is, how I wrote A means completely this one, entire this total circle. A means is the entire circle. Union B minus A. B means B with the excluding A. That means this secondary part, this part. Okay. So and A union B minus A gives you the A union B. So I am applying probability on both sides. It becomes what? P of A union B is equal to P of A union of B minus A. So again I am explaining how A union B can be written as here. A union B, how A union B can be written here is A union of B minus A. And A means completely full set. A means completely full set, and union of B minus A. B minus means excluding A from B. Excluding A from B means you have to exclude A part from the B. A part from the B. That means it gives you the part of B which is independent of A. There is no inclusion of A in that B. So A union B, that is called the A union B. So applying A union B on both sides, it becomes P of A union B equal to P of A union B minus A. So next one, how it is written as P of A union. Now next, how it is written as B minus A can be written as B minus of A intersection B also. A B minus U intersection of B also. How it will be written as? How we will see now. So from the figure we see it is A, it is B, it is B. You want to know the what is B minus A. So it is B. So so this is the this is the part this is the part this is the part we have to consider here. So this is the individual B. From B, total B, if you take out this small part, what is the small part is called? The small part is called, you already know that it is A intersection B. From B, if you remove this small part, that also gives you the B, only B, without it excluding all the other parts. So that's why B minus A can also be written like this. B minus of, what is that exclusive part? That common part, this common part between A and B, that is A intersection B. Now it can be written as P of A union B minus A intersection B. So A plus P of B minus of A intersection B. How it is written? So P of A union P of B minus A intersection B. A union of B minus A intersection B. So you are writing A and B as two. Sorry, is union. So you are writing A union B minus A as two mutually exclusive events. That means mutually exclusive events means there is no common point between them. You see here, you are writing here and like this. There is a common point between them. Between this, it is this one. But you can say these also some mutual exclusives like that. That means this part. See here carefully. This part and 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 this part, and if you consider this part, there is no common event between them. Common event means there is no common point. They are touching, but they are not common. So that's why they are called the mutual exclusive event. Suppose a mutual exclusive example I am giving. If you are there is a die you are rolling. So the first event is I am declaring as 1 2 3, getting a 1 2 3. So another event declaring, I mean defining it is 4 5 6. So what is the intersection between them? So there is no intersection between them. So that's why the intersection probability is equal to 5. If at all you are taking 1, 2, 3 as one event, and another event is 1 5 6, 1 5 6. So there is a common event here, that is 1. So that's why there is one common event, 1 out of how many? 6. That's why the joint probability of this one is 1 by 6. But here if you are considering the 5 value, the probability is 0. So that's why the joint probability is the common probability here, it is written like this. That's why A union B can be written as A plus this event, A plus this event. So probability of A plus P of B minus A intersection B. And next one, it is P of A plus P of here. If you remember, if you see here, B and A intersection B also are mutually exclusive events. Here also they also can be written as P of B, that minus sign as it is P of A intersection B, P of A intersection B. So finally from this we can say that P of A intersection P of sorry P of A union B is equal to P of A plus P of B minus P of A intersection B. This is called the joint theorem of probability. Joint theorem of the probability. So P of A union B equal P of A plus P of B minus A intersection B. And I am assuming the events are not mutually exclusive here. A and B are not mutually exclusive. We are converting them into mutually exclusive events like this: A union B minus A. We can call A and B minus A are mutually exclusive events, but not A and B. This is the first case of additional theorem of probability. And coming to the next one. Now the second case, if you consider like this, right, this is the extension of the theorem. Yeah, this is A, this is B. Now say this is A, this is B. There is no common events between them, and I can say that there are no common events, means that means A intersection B equal to 5. That means P of A intersection B is equal to 0. A intersection B is equal to 0, and I can directly say that my P of A union B is equal to individual events probability P of A plus P of B minus P of A intersection B. Usually it is 0, means there is no significance for this, so that's why I'm adding P of A intersection B, means I'm adding directly. So P of A union B equal to P of A plus P of B minus P of A intersection B. Okay, so this is the second part of your proof. So there's in the first part you are assuming the events are not mutually exclusive. In the second part you are assuming events are mutually exclusive. So these are the only two combinations of two events. So from 1 and 2, we can say that we can we can say that the joint probability P of A intersection or A union B, anything you can write. P of A union B is equal to P of A plus P of B minus P of A intersection B. So hence the theorem is proved. So to find the theorem, to show the theorem, how many events I am considering here? Two events. The two events in two cases. One is not mutually exclusive, another one is mutually exclusive. Okay. Okay, next one. Next concept is combined sample space. Combined sample space. So combined sample space means suppose consider I'm throwing consider I'm throwing a coin and a die together. Uh, both are throwing together. So this type of experiment is called the combined sample space. That means you are you are doing experiment with different materials, coin and die. So, but if you do same experiment with coin, two coins, it is not called the combined sample space. So for the combined sample space, how many number of outcomes are there? So to find out that one. So suppose I am assuming combined sample space. Suppose S1 is the sample space of coin, and S2 is the sample space of this one, and we can write like this: S1 intersection S2 is equal to sample space events. So coin has two outcomes. Coin has two outcomes, and die has six outcomes, and totally together 12 number of outcomes will get. This is called the combined sample space. Suppose you are having two coins, S1 intersection S2 intersection S3, and third one is your dice. The total number of outcomes are 2 into 6, and that is 24 number of outcomes will be. Suppose if you write the sample space here, it is like this. So 1 comma t, 2 comma t, 3 comma t, t means time here, 4 comma t, 5 comma t, and 6 comma t is the one combination. The second combination is 1h, 2h, 3h, 4h, 5h, and 6 comma h. So see here. So there are totally how many? Totally 12 number of outcomes you are getting. So this is called the combined sample space. So for example, if you say I'm rolling two dice and one coin. So the sample total number of outcomes are two dice having 6 into 6, and one coin having total number of outcomes 2, and totally it is having totally 72 number of outcomes. 72 number of outcomes. Suppose if you want to write one event, that is one on the first die, one on the second die, and assuming t. Another one is one. Likewise, here there are totally 72 combinations will come. So this is called the combined sample space. Combined sample space. Okay. So with this, I will complete the today's concept. The next class we'll discuss about total probability and uh, Bayes theorem. Bayes theorem. Thank you. Thank you very much.